problem, let's go 55 together. So it's the very back page of that packet from yesterday. The Ravens scored 13 more than 3 times the number of points that the Bengals scored in their last game. Okay, that's very confusing. It said if the Ravens scored 40, how many points did the Bengals score? So I'm asking you, how many did the Bengals score? So that is my variable. So I'm going to say X would be the points.
Oh, I don't miss this.
The points the Bengals scored. Oh, man. So now it said the Ravens scored 13 more than. What does more than mean?
Plus 13.
13 plus or plus 13. 3 times the number that the Bengals scored. So that would be
3x.
3x. And the Ravens scored 40, so we would say
Plus 40. Or equals 40.
equals 40.
Okay, good.
Now this is an equation with its long. So subtract over our 13.
What? Oh.
Divide by 3. So x is 9. So they scored 9 points. So if there's something we don't know, we can write an equation to solve it. All right. Let's go to 59. So the total cost to rent a pontoon boat for 8 hours can be represented by this equation. If Brianna can spend a maximum of $200, how many hours can she rent the boat? So what would we do?
X is hours.
Or it already used H for the hours,
Oh.
but yeah. Because if we were writing our own equation, we'd probably do that, but it gave it to us. And we know she has $200, so what would I say? Equals 200.
Yeah.
So then we solve this. So 30H. Well, it's 135. So she can rent her boat for 4.5 hours. Okay, so that is the end of this packet. The 2 questions that I want you to do remaining on this are 56 and 58. So that's the last 2 on this, and then I'm going to give you guys the next one. All right. So, packet 2, we are going back to the very beginning when we started talking about all things related to lines. So, when we talk about just a little bit of vocab, so we're all on the same page, a relation is just any set of ordered pairs. I don't know why my pen. So any grouping of numbers. The domain represents x or y. Domain is the x values, and the range is the y values. If it's a function, which of those can't repeat? option is the x. So if it's a function, the x can't repeat. If you're looking at the line or up the graph, we could use the vertical line test. To check to see if that is the case. All right. So let's look at a few. Shoot. Number one, if I give you this set of ordered pairs, what is the domain of that? All of the x's. So what are the x's we used?
-1, 2, 5, and -1.
-1, 2, 5, and since I already wrote -1 once, I don't have to list it again. The range is the y's. What y's did we use?
7, 3, 0, 2.
Does the order matter on these points? No. Is this a function? Remember, it's a function if it doesn't have any repeating x's. So, no. Because if I look, -1 was used twice. So it is not a function. If I look at number 4, when we're looking at a graph and talking about domain, I always said domain goes from left to right. What is the first x value we use? -3. Let's say that is less than or equal to x. And what's the last one we use? +3. But that one had an open circle, so we just don't do the equal to. So it's -3, less than or equal to x, less than 3.
Wait, but how do you know it's less than? Because it's negative.
You always go small to large, so these symbols are always going to be the same. So it's saying x is bigger than -3, but it's smaller than 3. So those symbols will always go the same direction if you go from left to right.
Just the equals will be different.
Yep. So the range, we go small to large. What is the smallest y value? -4. Would it,
Sorry.
the lowest point of my graph is
Oh,
right
never mind. Okay.
And that one hit, it wasn't an open circle, so it gets an equal to. Range is talking about y. What is the highest y value we hit? To decide if this is a function, we're checking, does it pass the vertical line test? If it's a function, no matter where I draw my vertical line, it can only hit my graph once. If anywhere a vertical line hits it twice, it is not a function. Does a vertical line ever hit this twice? No. No matter where I draw a line up and down, it only hits my graph one time. So this is a function. Let's do another one of those. Let's go to 6.
So,
Is this the function part of it?
yeah, so like, is the first one we did, like correlate to anything that the fourth one was?
Yes. So when I say the vertical line test, I'm saying, essentially saying x can't repeat. If you hit the same x value twice, so if you look at like number 6, right here, this point x is 1, and that point x is 1. So we hit the same x twice. In terms of a vertical line, that means if you draw a vertical line, it hits my graph twice. And if that happens, is it a function?
No.
No. So this one would not be.
So, like, I know we gotta do the domain thing, but to find the function, we only gotta look for if the x repeats.
Yep.
Alright.
So what's the domain on number 6? Where does my graph start? -2, and it goes forever, so it's everything bigger than that. So we could just say x is greater than or equal to -2 because we don't have a stopping point on this one. The arrows keep going. My range as this goes, it gets wider and wider. So one end is going down, one end is going up. What y values do we hit?
1 negative.
But it's going to keep going down as these arrows. So if I keep extending, it keeps going. So is there anything we wouldn't eventually get to? No. So what does that mean our range is?
All real numbers.
All right. So we're talking about functions from our graphs. We can also look at them in equation form, like function notation. So let's just try one of these. If I tell you f of negative 5, what is that asking you to do?
Substitute.
They're not on there.
Oh, yeah, put -5, oh.
Yep. Put the negative 5 in for the x. So this negative stayed. We just replaced the x with the negative 5. Two negatives in a row make a positive. So 5 minus 7 would be -2. So we're only changing our x. Okay. Let's try another one. Let's look at number 9. All right, this one, we have to do two things. We have to find f of negative 4 and f of positive 9, and then subtract them. So f of negative 4, if you go to your equation, you plug in -4 for your x's. You know, on the EOC, is there anybody standing over your shoulder judging you if you use a calculator on something?
No.
No, so if you need to use a calculator, do it. So if we put in -4, what do we get?
What?
So I'm finding the f of -4 first. So put a -4 into it. What's making you mad?
I don't
Like
under-
it ain't beaten.
This is bugging me.
Bro, what? Yeah, see,
Give me one more, that's negative 8.
Close. We're putting in a -4 for the x. What is -4 squared? That means -4 times -4. 16. Times 2? 32.
Yeah.
Minus negative would become a plus 4, which is 36.
This is not doing it for me.
Okay, so that's what I got, but I didn't think it just didn't make sense.
So which one do we do?
So it's asking us to subtract the two answers. So we have to do each of them separately and then we'll subtract. So f of 9, I put in a 9. So 2 times 9 squared minus 9. All right, what's 9 squared?
81.
2 times 81? 162 minus 9? 150. So this one just is like a 3-step problem. We had to find f of -4, we have to find f of 9, and now it says subtract them.
117. Okay.
All right, good.
I got that.
Yeah, this is making my brain do
I
some
don't
stuff.
remember doing none of this.
We did, I promise. It was like our first unit, so back in August, September. It's been a while.
Yeah, I remember despising
That's
this one.
ancient ages.
All right, let's look at problem 13.
So you look like you've been your first grade projection.
All right,
Isn't that an offensive thing? Just like,
problem 13. It's asking you to use the graph to find f of 3. So this says f of x, find f of 3. So it's saying if x is equal to 3, find y. That's all it's asking. So when I look at this graph, I have to look when the x is 3. So 1, 2, 3. Yep, we're finding that point on the graph, which is 1, 2, 3, 4, 5, 6.
Oh, wait, what? I didn't know I was.
I'm lost.
So we're looking when x is 3. So on our graph, okay, if the x is 3, that means we go 3 to the right. Where is that point on our graph? So it's right there. The y value of that one is 6. So if I'd said like f of 1, when x is 1, what's my y?
-2.
-2. So you're just telling me the y. All right. Zeros. We've been doing this with some of our quadratic stuff. Zeros we know are where it passes the x-axis. We did this on our last test. To find them, we set it equal to 0 and solve. So we can get them from a graph or from an equation. So if I said number 16, it's not a quadratic, but the 0 is just where it hits the x-axis. What is that point?
-3, 2. Wait, what?
Oh, you did 15. Yeah, 15 is 2. 16 is -3.
17's -1.
17,
And something else.
-1, and 4 to get to it. Okay, so we're just looking at where it crosses the x-axis. Let's look at 20. It's one of the equations like we had on our test. So if I'm wanting the zeros, I want you to set this equal to 0. What do we have to do to it? What's that? Remember we factored? So we're looking for two numbers that multiply -40, add to +3. And then we set those to 0. So x plus 8 equals 0. X minus 5 equals 0. So you might just recognize it's the opposite, otherwise you solve them. So we get -8 and +5. Okay. So that stuff was pretty recent. Are we okay with that? Let's talk about slope a little bit. Alright, so when we're talking about slopes of lines, there's really 4 different options. If we have a line that's increasing, the slope is positive. If our line is decreasing, then our slope is negative. If you have a horizontal line, what's the slope of that?
It's no. 0.
And if you have a vertical line, no slope, it's undefined. So if I looked at problem 24, Remember, slope is just rise over run. So if I asked you for your slope, we go up 1, 2, 3, 4. We go over 1, 2, 3, 4, 5. So what's our slope? Rise over run, 4 over 5. Just to kind of jog our memory, all these different things we've
What?
crammed into the last 2 years. So you just count from one point to the next. How far up do you have to go? How far over do you have to go?
Does it matter if we like,
Boom.
which point we do?
No, if you had started on this one, you would say I go down 4 and backwards 5, and -4 divided by -5 would turn
Okay,
into
so
a
if you
positive.
get a negative, then you do
If they're both negative,
Okay.
it becomes positive. If we don't have the graph to do rise over run, remember we had a slope formula, y2 minus y1 over x2 minus x1. On the EOC, you are provided a formula sheet, and this is on there. So you just have to know that it represents slope.
No. If you go up first, and then it will, wait a minute, no, yeah, that'd still be the same. Yeah, cause if it's just on the bottom, you still have to do what she says, and then just go up to the top.
So let's try that from 28. So remember, in this point, this is like the x of the first order pair, the y of the first order pair. X of the second order pair, the y of the second order pair. So we do our formula. y2 is -4. Minus y1 is -1. Over x2 is -3 minus x1 was -12. So -4 minus 1 is -3. Change, so -3 plus 12, 9. And we usually put these as a fraction in lowest terms, so that reduces to
1/3.
-1/3. All right. I'm going to do just a little bit more. We're not going to get all the way through this packet today either. We'll finish it tomorrow. But I do want to talk a little bit about the equations of the lines. So, equations of lines, they could be a couple different ways. Slope-intercept is what we're most familiar with, y equals mx plus b. Standard form is when x and y are on the same side. So problem 32, if I said write the equation of the line with a slope -1 and a y-intercept of 4. Slope is which variable? M. So to say my m is -1. The y-intercept is what variable?
4.
P. And that's our 4. So m is slope, b is the y-intercept. Alright, I'm going to do 2 final examples. 35. If I asked you to put this in slope-intercept form,
Y equals 4x minus 10.
okay, so we need to, so right idea, we have to get the y by itself. So let's
10y
solve.
equals 4x minus 10.
So if I want to move the 4x, we would subtract it. So we have 10y. These aren't like terms, so I can just write it as -4x minus 10. Then what would we have to do to everything?
Yep.
Yep.
Yeah.
Divide them by 10. So we get y equals -4 over 10 is -2/5. -10 divided by 10 is -1. So we get y equals -2/5 x minus 1. What is the slope of that? -2/5. What's the y-intercept?
-1.
-1. All right. Last example of the day. X and y intercepts. Remember, that's where it hits the x and y axis. So with the x-intercept, your y is equal to 0. And then we can solve for the x. Y-intercept, our x is equal to 0. And we'll solve for y. So you basically just make the opposite variable 0. So on 39, if I'm trying to find my x-intercept, where it hits the x-axis, that means y equals 0 if we're on the x-axis. So if I want to get x by itself, okay, so -9 equals -3 halves x. And then what would we do?
Divided by -3 halves.
Mm-hmm.
I keep saying
So we're just solving for x. Sorry, I kind of ran out of space there.
Wait, okay, so you divide, so you have -3/2. So -9 equals -3/2, and then what?
We're dividing by the -3/2 to get x by itself. So it's -9 divided by -3/2. And what do we get for that? You can do the -3, put the -3/2 in parentheses if you're plugging it in your calculator. So -9 divided by parentheses,
Oh, yeah, I just did that back.
and we should get 6. So my x-intercept is 6. We hit the x-axis at 6. If I asked for the ordered pair, the x was 6, the y was 0, because we started out putting in 0 for y. If I ask you for the y-intercept, that means x is 0.
Y equals 9.
Mm-hmm.
Yeah, I'm so good at it.
And so that's the point when x was 0 and y is 9. All right. So, today, the first packet we will either turn in at the end of class or beginning tomorrow. So that one's due. I gave you guys 2 more problems on that one, 56 and 58. On today's packet, okay, we are going to do 3, 5, 8, 14, 19,